This is for Year 11 methods. It comes out of 14L, question number 4, sketching these tangent functions given the domain negative pi to pi. So this domain goes over a distance of 2 pi. If I'm looking at 4b, the tan of x plus 2, n is a value of 1, so the period of this is pi divided by 1, or pi. I'm going to draw 2 complete cycles. It's the tangent curve that's been moved up 2 units. So moving up 2 units is not going to change where my asymptotes go. So since my period is pi, I'm going to be half a pi either side. So I might put an asymptote there at x equals pi on 2, and an asymptote over here at x equals minus pi on 2, which means I'm going to finish at minus pi, and I'm going to go across to pi. Normally my tan curve would go through like this, and it would go through at 0, 0. Because it's been moved up 2, it's now going to go through at 0, 2. But it's still going to be asymptotic. It's going to approach that asymptote. But that's going to cut through at 2. I don't have the level of mathematics without a calculator to find out what that x-intercept is, because if I set y equal to 0, I don't know from my table when the tan of an angle equals 2. I only know root 3 on 3, 1, root 3, and 0. I don't know 2. So I'm not going to label, without using some technology, that particular value. So I would also have it going through and finishing here. And it's going to start at 2 and continue on like this. So I know that endpoint, and it's a concluded endpoint, is minus pi and 2, and that endpoint there is pi and 2. And that's just a translation up 2 units. I could actually label that x-intercept. No, I won't. Okay, part C. I've got 3 tan of x, and we're going to move it down 3 units. My period is still pi, so my asymptotes are going to be identically the same as this curve over here, except instead of moving it up 2 units, I'm going to dilate it by a factor of 3 and then move it down 3 units. If I draw my axes, that can be pi on 2, that can be pi, this can be minus pi on 2, and that can be minus pi. I'll have an asymptote at these values, so I'll label the asymptote. I know that it's going to normally look like this, but be steeper, and then it's been moved down 3, so it's going to go through there at negative 3. And it's going to start here at negative 3. Oh no, it's going to finish there at negative 3, so it's going to have this half. So that's correct. And here I'm going to have this bit here. So that's going to be minus pi and minus 3. That's going to be pi and minus 3. That's going to be minus 3. And I can actually work out these x-intercepts because when I solve this for 0, 0 equals 3 tan of x minus 3. The 3 comes over and gets divided by 3, so I get the tan of x equals 1, which means on my table I know that x equals pi on 4. So that's dead middle at pi on 4, which means that's at minus 3 pi on 4. And that's how you draw them.